So we're taking a look at some log problems here, but the big part of this question is trying to do these without using a calculator. And so in order to do that, we need to know several things about exponents and about logarithms. If we take a look at the first problem, log of 8 plus log of 125. First thing we need to know about this is both of these logarithms do not have a base written in, and if there's no base written in, it is a base of 10. So just like in your calculator where it doesn't have a base written in, they're base 10. If they have the same base, I can then use the product property of logarithms to write it as one log. So I can write it as 8 times 125. So this now is log of 1,000. So again, the base is 10, and a logarithm is like an exponent. So basically this question is asking 10 to what exponent is going to equal 1,000? And that would be 10 to the third will equal 1,000. So this equals 3. Taking a look at problem B, we're going to use some different information about logarithm. So log base 25 rather, of 125. So again, this equals some sort of exponent. So if I switch this to its exponential, I would have 25 to the x equals 125. So basically this question is asking 25 to what exponent equals 125. So now we need to figure that out, which this is going to get us into some fractional exponents. So if you recall a fractional exponent, the denominator of the fraction is the root you're taking. So if I take 25 and I take the square root of that, I get 5. And 5 to the third power equals 125. So that means if this exponent, I want to take the square root of it and then put it to the third power. That exponent then is 3 over 2. Because again, fractional exponents, the denominator is the root you're taking, the numerator is the exponent. So what that all means here, one last time, is 25 to the 3 over 2 is going to equal 125. So my answer here is 3 over 2. Problem C. When I have the 1/2 out front, what I can then do is use the power property in reverse. So I'm going to take this 1/2 and it's going to go back as an exponent. So based off of the last problem that we talked about, a fractional exponent means I'm taking the square root of 25, the square root because that's the denominator, and then I'm putting it to the first power. Well, that's just going to be 5. So if I do that, I can then simplify this problem to being the log of 5 plus the log of 20. I'm now going to use information from the first problem to write that as one logarithm. It's log of 100. And again, the base is 10. So 10 to what exponent equals 100? And the answer is 2. And now the last problem. If I look at this one as 7 to some exponent equals y, if I want to switch this to a logarithm problem, this part right here in blue, if I want to switch that to a logarithm problem, my base is 7, so it's log base 7. I would be taking log base 7 of y, and it's going to equal the exponent. So once I have this, now what I can do is say, well, it's not actually an x here. It is this exponent, log base 7 of 12. So I can replace this x over here with log base 7 of 12. So now that I have a log base 7 and a log base 7, these two have to be equal to each other. So this equals 12.